us now deal with one more nested loop program, which will now nest a while and a for. Don't feel with the previous examples which we have shown to you, saying that a for has to appear within a for so that we can call it as a nested loop structure. No, a nested loop structure can have even a while within a for, or a for within a do while within a while also. Let's write a simple code to check whether or to generate the Armstrong numbers. We have seen the Armstrong numbers in the while loop section. There we saw that how the Armstrong numbers are found. If the sum of the cubes of the individual digits equals to the number, we call that number as Armstrong number. For example, if I have a number as 100, what is the sum of the cubes of 100? 1 cube plus 0 cube plus 0 cube, because it is a 3-digit number, hence it is cube. So 1 plus 0 is 1. Is this number equal to 100? No. So it means that number is not Armstrong number. Suppose if I enter 153, 1 cube plus 5 cube plus 3 cube, 1 plus 125 plus 27, which is equal to 153. Hence 153 is prime number. I am supposed to now try for all the numbers from 100 till 999. Whenever I find such numbers where the number and the cubes of the digits are going to match, we have to display that particular number on the screen. So we know that while loop is used to produce these cubes of digits, because here I am supposed to extract these digits. When the extraction process has to be done, it has to be done for a while loop. A while loop will now extract the digits and lets you find the cubes. And that particular cubes need to be found with if. And this entire section has to be now enclosed within a for. How a for? Because when I say a for loop will provide all the numbers from 100 to 999. This will be a revision of all the control structures which was today. I'll revise the if else, I'll revise the while, I'll revise the for. So here, for provides the number, while it checks or finds the cubes, and if checks whether it is Armstrong number. Let's look at the program to implement this particular generation of Armstrong numbers. Now, since it is stated that I'm supposed to do it from 100 till 999, I'm not supposed to read any input from the user. So I'll directly display the output, printf the Armstrong numbers between 100 and 999 are. So it displays particular numbers. And then it will go from 100 till 999. What it does is, it will first assign this particular I to n, because why the value of I has to be copied out to n. If I is disturbed, then probably the loop operations will not be executed properly. For that reason, what I need to do is, I need to make a copy of this particular I onto n. So let this n be 100. So I'll make a copy of I onto n, so that if n is disturbed, I is still intact. Let's take the sum variable s as 0. So n greater than 0, is 100 greater than 0, true. 100 mod 10. 100 mod 10 will get you 0. So n equal to n by 10, n will reduce us to 10, because 100 by 10 is 10. S equals to s plus r cube. So in this case, r was not 0. So s plus r cube is 0 cube, that is 0. Again go back. Now this curly bracket will take you back to n. N is 10, 10 greater than 0, true. True, since 10 mod 10 is 0. 10 by 10 is 1. S equal to s plus r cube is 0 cube plus 0 is 0. Again go back, r n becomes 0, because n mod 10 is 1. And here you will set s as 1, because 0 plus 1 cube is 1. So again go back, and when we test the loop, the while loop falls. Your n has reduced to 0, hence while loop fails. When while loop fails, it will check whether s is equal to I. Now see, the value of n should be compared to I. Most of you might have ended up with an answer called as n, because in this case I can't use n as n reduces to 0. I have made a copy of this particular n onto I, so I is set to n, since s equal to I. If that is true, then print the value of I. So is this 100 equal to 1? No. Equal to 1? No. Since we will not print this particular value. I have shown this execution for 100. Similarly, this curly bracket will go back and does it for 101. So 101 copied onto n, then again all the operations are repeated. N is now 101. Again all these operations are done. All these operations will help us to say that whether the cubes of the digits, and then I'll compare that S with I. If the value of S matches with I, in that case it will display that particular I. If the value doesn't match, it will not do any operation. Go back and keep on testing for next value of I. So here we keep on doing it for different values of I from 100 till 99. Since I'd use the range from 100 to 99, all these three are 3-digit number, hence I'll always use the cube. If it is a 2-digit number, then I'm supposed to do it for square. If it is a 4-digit number, then I'm supposed to do it for raised to 4. Generally, in most of the exams, whenever it says that you're supposed to do it for cubes, it will be always a generation of 3-digit numbers. So this is how we implement a nested loop example where a while is nested within a for, where for provides the numbers and while checks or finds the cubes of the number, and a if will check whether that particular number is equals to the sum or not. If that is true, then it will display that particular number. So here a for has been used, a while has been used, and as well as if has been used. Revise the entire program with your own value of I. So I have taken I as 100, 101. You can try for I different values of say 102, 103, 104, 105. Say for 10 values. If it works for 10 values, it will be assured that it will even work for remaining values also. Thank you.